Hey YouTube, welcome to my brand new episode, and in this episode we've got an amazing character controller in store for you. As we all know, we have used the Unity default character controller, and honestly, it's really bad. It's actually terrible at what it does. And I, when I use a script, I would like to know what components are using and actually making it work. So not being able to see the code of the character controller script is a big down for me, and I just wanted to create something brand new for my game. And I've created this amazing character controller that requires no rigid bodies, no colliders, and runs fully off of just one script, which is this mouse player controller. And I know it says mouse player controller, but trust me, you can use this script for FPS controllers, third person controllers, and basically any type of character controller you would like. So let's see the settings we have. We got a move speed. This controls basically every setting and how fast the gravity works and everything. The axis speed, how fast your horizontal and vertical movements are. Your rotation is just for the mouse script, so that's how fast it rotates. Your strafe speed, this I haven't set up yet, but it's not necessary yet. That's very easy to implement if you want later. We got the physics header here, and we got the gravity and how high the jump is. And this sensor local, okay, this is very important. So this yellow sphere here is basically your wall detector. So it detects if there's a wall or a collision object, and it does a heap of calculations. We'll go into it later. Your surface slide, okay, so you go and you collide into this wall, and you have a slight angle, and you'll slide on the wall. So you won't just stop there because you collided. Okay, and we got slope climbing speeds and all this fun stuff. We got to attach a camera for the player, and we have a quick layer mask that just excludes the player from the layer mask. So as you can see, the player has a layer mask. Okay, the capture collider is disabled, and there is no rigid body. So let's play this, and we have a little slope here. Okay, as you can see, there are a couple of debug rays just to help visualize. Let's actually turn the gizmos off. Okay, so if I go collide, as you can see, we're sliding across the wall, and if we jump, we can jump real smoothly, and we're climbing up the wall, no problems there. And let's go right back down. And we've got a nice smooth jump animation, and it's not animation, actually it's fully script controlled, and this is just in prototype. You could take this and work on it and modify it so much more, and it's actually really amazing. It's got so many little features that I've implemented, so you don't go through walls, you don't the gravity doesn't take you through the ground. So many awesome controls that I can't wait to get into. Okay, so I've got this little scene set up here anyway, so I'm just going to leave this as is, and I'm just going to delete this script, okay, and actually, no, I'm not going to delete that script because those values are quite important to me. So let's just disable this and put it there. Okay, let's create a new scene and begin this character controller. Okay, I'm just going to create a quick cube, center that out, and I am going to be moving quite quickly as this is kind of a, let's say, a advanced tutorial because it has quite a lot of features that may be new to you if you are new to developing games in Unity. Okay, so let's just save the scene as YouTube tutorial. This is actually a project that I was creating for my new game, but I decided, no, this is amazing character controller, and lots of people have searched this up online. So I was like, yeah, why not create a video and show people how to do this because it's pretty awesome. Okay, so that's a little slope test over here, and let's copy that and zero out the rotation again, and just put 90 on the z-axis. So now we have a little wall. I would actually like to turn this on a 90-degree axis and 90-degree rotation and put it here, because another problem that happens when the character is sliding across a wall is it slides, it slides, it slides. It stops here, detects this, and the wall tells it to go left, and this tells it to go right, so it like zeroes out and goes through the walls. So I want to test to make sure that the player isn't doing that, which is not very good. So as you can see, very, very simple scene. Alright, let's go and create a new script. So in my character, I will create a new script called YouTube controller. Yeah, awesome name, I know. Alright, let's get a cylinder and zero this out. And I promise you, oh wait, what am I doing? Oh, I'm so dumb, sorry. Firstly, actually, I'm just gonna parent all of these to, bad idea. Just get an empty and parent all make them a child of the game object. I'm just gonna call it underscore level. Put it at the top, just for my organization skills. Alright, let's get 3D object. Let's get a capsule and zero that out, and let's bring that right over here. Okay, I got a little capsule here. Alright. Let's get our main camera, and little trick that actually saves me a lot of time. Shift Command F, and what that does, Shift Command F, I'm not quite sure what that is on Windows, but Shift Command F, as you can see, changes the camera to the scene view. So if I go Shift Command F here, it will change over here. So just a little shortcut. It's really, really helpful. In my opinion, it was really helpful when I started. Alright, so let's click here and YouTube controller. Okay, some quick stuff that we're going to do. We're just going to disable the collider. We don't really need that right now. Let's, you go add layer, right? And you add a layer called player and ground, okay? Those two are kind of important. Okay, let's set a layer for the ground, and for the player, let's set the player layer. And let's open up the YouTube controller. Okay, just loading them out of the screen. And let's open this up. Hopefully it loads. There we go. Alright, let's begin. Let's start by writing out all the variables we need. So let's just get rid of this. That's kind of disgusting. Okay, to keep everything neat and tidy, let's create a little header called speeds, and we'll make a public float called move speed. We're going to make another float called axis speed, and another float rotation speed. We won't be using most of these actually, but I can try implement it if I make another part on this and I improve the system. Another header called physics public float. So what these header things actually do is, in the inspector, it makes it nice and organized. So let me just show you here. So I've got physics and speed. If I let this load real quick, anytime would be good. Alright, so you got like the speeds title and a physics title, and you got your variables under there. It helps keep it nice and neat. I quite like it. I use it all the time. Header, we're just calling this external. So let's camera, player, camera, oh god, sorry, camera, and public layer mask, and let's call this exclude player. So if you guys ever refer back to this, you'll know exactly what layers you need to add to that. So let's just add some private fields now. So these two are very important. This just tells the system if your character control is grounded, and this modifies the amount of gravity that you are currently experiencing. So if you're on the ground, the current grav would be 0. If you're in the air, the current gravity would be the gravity, basically, negative gravity. So pretty basic stuff there. We're just gonna click on a controller. I'm gonna get all this set up, okay? So because I always run the game and I'm just wondering why nothing is working, so I'm just gonna attach my main camera, if it would attach. Yeah, nothing. We're just gonna click on everything and go down and untick the player. Make sure you untick the player, or it's not gonna be pretty. Gravity. Okay. Uh, I remember I had to do a lot of tweaking for this, so let me just quickly go back and just learn what I had to use here. Okay, so I'm just gonna copy this. You guys don't need to do this. You just copy off mine. But I just want to know real quick what features I had. Alright, as you can see, the gizmos automatically draws when I attach this. Alright, so my move speed was 4.9. My axis speed was 0.05, which actually slows it down because too fast, if it's too fast, the player actually skips through space, like too far for the raycast to work. So it would just like go from here, and it will skip through here to here, and it won't even give the raycasting system a little bit of a chance to check if there's a wall. It just skips right there. So we don't want that. We need to actually be slightly to speed. Doesn't mean it has to be slow. It can be actually quite fast, but not too fast, obviously. One gravity, we're going to go negative 0.15, and jump force is 0.2, and yeah, okay, that's good. Okay, let's add the other variables now. Alright, one second. Okay, alright, sorry about that. Alright, header, we're gonna add surface control because we need different types of like a what do you call speeds, because yeah, you just need them because you wouldn't go the same speed if you were sliding across a wall, if you were I don't know, walking normally. So surface slide speed, and then we got the public float slope climb speed, and public float slope descend speed. Okay, slope descent speed I don't think we will be using in this tutorial specifically, but keep it there just in case, because it's always important. Okay, we got our sensor logo. Okay, for this we just go 0, negative 0.56, and 0. This is the best position that I thought would work for me. You can always modify this. And actually, word of advice, what I actually previously had for my character controller was 5 sensors, and instead of checking from one sensor, I would have my system loop through each sensor and raycast, because if you had like a pole going across this height, this sensor wouldn't really pick up that pole, and it would say, okay, there's no collision there, and it will go straight through the pole. That's not really needed for my game, so I haven't added that. But if I were you, I would add like 5 sensors. Just saying. You could do that if you want. If you don't want that, all good. You don't have to. Okay, so now we've got a proper little controller set up with all our variables, which is really, really cool. Alright, now let's begin the actual coding. Alright, so let's actually, this is really disgusting and I don't want to see this. Another cool little tip, let's call hashtag region, and we're going to call these variables. I didn't know this for quite a while actually, and I regret it. It was amazing once I learned it. I just go minus. Whoa, they're all gone. They're hidden now. It's amazing. I know. Okay, so firstly, we're going to give you a bit of visual. I believe that visuals are like the best way for me to understand what's actually going on in my own game. So hopefully all of you are aware that there's a method called onDraw Gizmo, and it's really helpful. Basically, it's like a handles except in scene view. So let's call box position. Actually, no, we are not going to do this now. Let's just call this vector 3L is equal to transform point. Okay, sensor local. Okay, this is this is to show you where the little sensor is. Okay, actually, let's make the color of this yellow. Okay, so what this should do now is just quickly show us. There we go. Hopefully you can see that. How to show this to you without getting rid of this. Yeah, hopefully you can see that. It's a little yellow sphere, and just shows this. If I move this up, you can see that that is moving. And how this works is we convert the world space to local space coordinates. So this is relative to your transform position. So hopefully that makes sense to you as well. Alright, so I'm just going to go from the top now, and let's begin. Alright, so we're going to make a private void update, and let's create a gravity. Okay, so I'm just going to lay out the methods that we will need, and I'll just uncheck them as we go. So jump, we'll need jump one, we'll need a simple move, and these are laid out in a specific layout. So whoa, what happened here? These are laid out properly in order for it to for the directions to accumulate properly in order for everything to work and stuff. Okay, so private vector 3 move vector. Alright, that's cool. We just need a private move vector, and that will be accessed later in the script to in the final movement to move everything. So let's create a private void simple move, and you can see I'm doing everything private. You don't have to. I just like it because everything's just neat and orderly, and I like that. Okay, so hopefully you're aware of the input.getAxes commands. They're quite important for making game. I mean, you could do it without that, but it would be pretty bad. So, okay. Before we do this, so this is how it's gonna work. All right. So we're gonna get the inputs, input axes, right? And that basically gives a direction, right? All right. So that gives a direction, and what we're gonna do is we're gonna pass that direction into a method. So we're gonna call this method vector 3 collision slope check, and vector 3 direction. Okay, so basically what we're going to do is we're going to pass in a direction, and this is going to give back something, or it's going to move the player. So this is kind of cool. All right, so let's I'll code it, and hopefully I can explain this properly along the way. All right, so our move vector is equal to a collision slope check, and we're going to pass in the direction new vector 3 input.get axes, hurry if I can spell, and 0 because we don't want any direction in the y-axis. That's all for our gravity and jumping stuff. And get axes vertical. And if you were wondering, I did do all of this myself. So yeah, if you guys use this, just and use this in a tutorial, just a shout out would be cool. Yeah, alright, so move vector. Alright, okay, so we got this. So we return a vector 3, and this is also vector 3. Therefore, we can use this to return an overall vector 3, inputting the direction. Hopefully that makes sense. Alright, now let's fill in the collision slope check method. Alright, so we're going to create a little vector 3 called D, which is transform direction. You should hopefully be really familiar with this. So basically what it does, it takes the direction and converts it into your, let's say, local direction. So, this is what I meant. You hopefully you know the basics. So it converts your non-local direction into a local direction, if that makes sense. And vector 3L transform point, okay, and sensor local. So this is basically exactly what we did here, except we're doing it here to get a vector, right? So we're converting this from world space to local space. Those terms should make sense to you. Okay, we're gonna quickly create an array and call it a new array, and we're gonna pass in L for the point where the ray starts, and D for the direction that the ray goes in. And we're gonna create a quick empty raycast hit variable, and we're gonna go if physics dot raycast ray out hit. So we're passing in the ray, we're getting the hit, and the maximum distance is 2. This is a very specific number, and we're not going math f dot infinity because performance issues, and we don't need more than 2 anyway. And the layer mask is exclude player. Alright, now we got this. This is great. Okay, so we'll check. Okay, 2 is specific, but we're not gonna be like, oh, if the wall is 2 away from us, we're gonna collide. No, that's way too far. So we're gonna do if hit distance is lower than or equal to 0.7f. This is also a really tested number for me that worked for me. It was really cool. And now we're gonna just draw a bunch of lines to explain to ourselves what's going on. So we're gonna draw a line from the transform position to the hit position, and we're gonna make this a yellow color, and we're gonna make this last for 0.2 seconds. Okay, so basically at this point, let's explain here. Alright, so we've got the direction, the local position. We're sending a ray in the direction at a maximum distance of 2. We're excluding the player, and if the distance is lower or equal to 0.7, we are drawing a line. Okay, so far. Alright, this we're gonna create a vector3 temp, and we're gonna create a vector3 dot cross. Okay, this I do not expect you to know. Alright, I don't know how I'm gonna explain this to you. Hopefully all of you know what a cross product is. So this is just a unique combination of cross products in order to get the right direction for you to slide against the wall. So just search up vector3 cross products, and you can understand all about them. They're actually quite easy, but I really can't explain cross products without like a sketch pad. I'm not the best at cross products myself anyway, so okay, let's draw a ray from hit dot point, and we're gonna no, I'm very done. So let me quickly explain what I'm doing here now, and I'm so sorry that I can't explain this properly, guys. It's even a bit complicated for me to explain this. Alright, so what we're doing now is we're getting a ray that starts at hit dot point. Alright, so where we hit, and it's just gonna go in the direction of this. Right? And we're gonna visualize all of this. This is important. Okay, vector3 my direction. Okay, vector3 dot cross. We're gonna cross the temp with hit dot normal. Okay, so currently these two vectors, you get the cross of the hit dot normal and the direction, and then you get the hit dot normal vector cross of the temp and the hit dot normal, and this should give you a direction, left or right, which way you're sliding against the wall. Okay, this is really interesting stuff that I just learned this now, and it's amazing. Okay, so we're gonna draw another ray from hit dot point, and we're gonna move it in my direction. Okay, and we're gonna times that by 20 just to show which way we're going, because normally these directions are really small and minuscule and we can't really see them. Okay, we're gonna create another direction called 02, and we're gonna do my direction times surface slide speed times move speed times axis speed. Alright, this is very complicated. The reason is, okay, we're timesing it by the surface slide speed because you're sliding against the surface, and since this is deriving from an axis method, we times it by the axis speed, and we times it by the overall move speed that affects everything in the scene. Okay, and okay, this is important, alright? We have to create another method at this point. It's called the private raycast hit wall check details. Alright. I don't know whether to show you right now. Okay, you know what? you know, I'm going way too complicated right now. I just want to quickly, actually, you know what? No, it's fine. Private raycast hit. We'll check details. Vector 3 direction. Okay, so remember when I told you, the player can slide across here, and it slides across here, and then it finds like it comes to this corner and it doesn't know exactly which way to go because it's colliding with both of these walls. So it decides the best way to go is straight diagonally through here. This is not good. This is really not good, and it's not good. So I created a quick solution for this, and it's quite effective actually. So we're gonna create a quick vector 3 called L transform point and sensor local. Alright, easy. And ray equals new ray elder. Okay, easy. Raycast hit. Okay, so we're just gonna send a ray from your sensor local in that direction. All basic stuff. The raycast ray out hit 0.2f exclude player. Alright, we're just gonna send a ray direction that is passed in from your sensor local point, and it's going to send out hit and a max distance of 0.2 because that's all we need, excluding the player, of course. And all we're going to do is return hit. We can't do much. We can't go return null because raycast hit is not a nullable type. I learnt that the hard way. Okay, so all we're going to do now is going to go raycast hit. We'll check. This is so disgusting. I'm so sorry. I'm just gonna separate. Sorry, wait. It's more like that. Okay, I'm just separating the lines of code because it's really annoying me. And raycast hit. We'll check, and we're gonna go wall check is equal to wall check details direction 2. Okay, so basically we get this direction, and we send it into the wall check details. Wall check details send a ray in that direction from the sensor local point and spit out a raycast hit. Basically, I did that so I don't have to write all of this in here, and it's disgusting. Alright, now we're gonna check if wcheck.transform is not equal to null. If it's not, alright, we're gonna do direction 2 times equals wcheck dot distance times 0.5. Okay, so all I'm doing is as you get closer to this wall, the distance will decrease, right? So you multiply this by the distance. So if you're sliding across this wall, right, and you're checking against this wall, and the distance between you and this wall, right, you and this wall is 0, the movement will stop. You know why? Because you're multiplying the direction by 0. If the distance is 0, you multiply something by 0, it's 0. So the speed will decrease as you move towards the opposing wall, so that collision never happens, so that you can't go through this. It doesn't look unnatural like you may think it would. It looks actually quite smooth. So all we're going to do now is going to go transform.position plus equals direction 2. That's it. We're going to add the direction to the position. That's all we're going to do. I'm just going to do return vector 3.0. Okay, so all of this was only if the distance was lower or equal to 0.7, right? If it's not, yeah? If it's not, we're just going to return the direction. The direction that was sent into this. So basically, if there's nothing, it just sends back what was received, so that the player just moves constantly in the direction that was given in the first place. So if physics.raycast didn't work, we're just going to return the direction again. So you're always moving in the direction that is passed in, unless you get something else, in which this method overrides movement and just returns vector 3.0. So this just equals vector 3.0, but the player is still moving in the given direction. So it's a really sophisticated method, and it really works. So now we got a proper moving vector, and let's just uncheck this. Cool, we got a simple move method. Alright, let me give me a second to recall my thoughts. Alright, next what we should do should be final movement. Alright, so we should do the final movement right now. So let's create it. Sorry, I'm really moving fast and I just can't process. Private void final movement, right? And vector3.movement. Oh, whoa. Oh my god. Vector3.movement is equal to new vector3 move vector.x negative current gravity plus jump. Okay. Sorry, this is a private variable. Let me just add this here. Make sure you add this private float jump height. I somehow forgot this. Okay, plus jump height move vector.z times move speed. Okay, let me explain all of this once I just finish this. Hopefully I'm doing a good job at explaining this. If any of you can't understand what I'm saying, any feedback on my explanations, please just leave a comment below and I will certainly try to work on that. Alright, okay, so final movement method. Okay, so we got a vector3 here, and basically what this is just combines all the variables that control movement in the whole script. That's why it's last. So let's just uncomment this. This is why it's last, because all of these accumulate, and then you just add basically all of them into one big movement vector. So the move vector from this is put into the x and z to control movement. The negative current gravity is this variable here, which will be modified in the gravity script, and this plus jump height will also be controlled in a different method called jump, and that will control smooth jumping without rigid bodies, which is, in my opinion, really cool. And okay, so basically we got a final movement here. So if I quickly play this, hopefully nothing. Okay, so we got a little movement here, and as you can see, okay, this is really interesting stuff. Okay, I want to just put it here, and let's not maximize, and I want to enable my gizmos. Alright, okay, let's go right here, and according to this, the forward vector is here, so let's just rotate you here. Okay, so we can move, we can see that we're moving, right? Boom. Can you see what's happening? Alright. We have no colliders. So I'm just moving with the arrow keys or the WASD keys. So we're moving according to the player's rotation, which will be modified later. If you're FPS control, you'd use like a mouse move script, and that stuff can be easily found online. So you can see I'm approaching from an angle. I actually want to visualize this a bit easier for you guys. Let's, in the final movement, can you add a debug.drawRay from your transform.position to transform.forward. Let's add a color.red, and let's set a duration of 0.2 f. Okay, if we quickly play that now. Okay, so now you can see clearly the red line indicates which direction the player is facing. Okay, so you can see if the player approaches the wall from this direction, it wouldn't just stop. They would slide this way. So let's see if it gives us that type of movement. And there we go. You see the player slides across the wall instead of going through it. Okay, let's do a little wall check test. Let's see. It goes to the edge and it does not go through the wall. As you can see, it's checking and it doesn't go through the wall. At any cost, it will never go through the wall. Let's just see if we did not have this wall check, what would happen? Alright, so let's just comment this wall check code out, and let's see the drastic disimprovements that we would have. Alright, so let's just aim it, which we should not be doing, but we can do that now because it doesn't matter. Alright, you see, we're going through, and what did I say? Look at that. Do you see that? it went straight through. You know why? It's colliding with this wall, and according to this wall, the normal is going this way. It doesn't care about that there's a wall there. That's why my script is really efficient. I'm sorry about my fan. Um, let's add that back in there. Very important script. Okay, piece of line of code. Sorry. And let's begin the fun gravity stuff, which was not at all fun for me. Actually, you know what? Actually, before we do that, I would like to add the mouse look script only because I really cannot deal with this, and it's really hard, like rotating the player manually. Okay, so let's quickly create a mouse look script. This is gonna be really simple stuff. We don't need any debugs for this. I'm sure you guys have done this many times over. So player camera dot screen point to ray input dot mouse position. Oh, not mouse. Present position. Alright, once we've got that, let's quickly add a raycast hit. Alright, now we've got a raycast hit. If physics.raycast ray out hit math f dot infinity disclude player. Of course, in the exclude player, what would happen if your mouse went on your player? It would just freak out. Not cool, right? If hit.distance is greater than or equal to 2, this is important, so the player doesn't glitch out. We're gonna create a quick vector called rpos, and we're gonna make this the hit dot point. Rpos.y is equal to transform the position.y. So if I put my mouse on the top of the wall, the player doesn't like decide to like have flying abilities and just go up. That's not cool. We're gonna have transform.look at, and we're just gonna look at the rpos. Wow, I know that was easy. If we quickly test this out. Alright, so, oh, whoa. That's not working. Oh, see, this always happens to me. I'm very disappointed in myself. Let's uncomment the mouse look, and also let's get ourselves on a better angle here. And I should select the main camera this time and use a little shortcut and quickly put the camera where it's at a good angle and change that to orthographic because I like orthographic. I don't know, it just looks cool. And as you can see, my mouse is moving. The game view is in the bottom right corner, by the way. I'm just moving and the player follows me. Let's quickly test our awesome collision detection here. Wow, it's working, right? It's amazing. I couldn't actually figure out how to do this for quite a long time. It actually took me a while to understand how to do this. I'm just gonna set this to green so I can actually see. So it actually took me quite a long time to figure out the cross method for this because I had my whiteboard and I was sitting there for ages just trying to find out the perfect cross equation for every direction. Okay. I'm having so much fun. Alright. Let's do the gravity. My least favorite part of the whole thing, I would say. But it works, so I'm not complaining. Alright. Okay, so how we're gonna do gravity. Very different to how you would normally do gravity. Normally you might just have like a trigger or like a quick raycast down check. These don't work. Trust me, these don't work. Okay, so let's make this is a professional way to do it, that you don't clip through things, you're not falling through ground. Okay, so when you raycast, you fall, and it's unpredictable. You might go here one time, or you might go here one time, you might go here one time. So what I quickly did was I said if you hit here, for example, what we're going to do is we're going to send a ray from your body down to the ground. If the distance is lower than 2 or so, we're going to quickly, faster than the player can actually recognize, we're going to clip up quickly back to the ground. So it looks like you're always on the ground. And that is how I did slope detection. It's amazing. That's how simple it is. It just clips to the bottom of the ground each time, and that's your slope detection. It works perfectly. And I found out this other cross method way to do it, but this, trust me, is a better way to do it. Okay. Alright, so let's implement this. And what we're going to do is we're going to do private void gravity. Alright, and before I forget, actually, I'm going to go right here and uncheck gravity from here. And let's have another method called private void fixed update. And I'm going to add the gravity in here too. I believe that the gravity method is so vital to our game that it needs to be referenced twice. You can take it out of one. Most experts in Unity will disagree with this method and tell me I'm not very smart, which I completely agree with. Okay, so let's create a quick vector 3. Alright, so I forgot to tell you how I'm doing gravity. So we're going to create a quick box around the bottom of this player. If it's not enabled, we're going to fall. Okay? If the box is not touching anything, we're going to fall. But there is a quick problem. If the box, for example, if you're in this wall, you jump against this wall. I don't know why you're jumping against the wall, but you do that for some reason. You get stuck in the wall. You know why? Because the box goes around your player, and it's telling you that there's something colliding with the box. So you must be grounded, but you're not grounded. So all you gotta do is raycasting to the rescue. I know. You send a raycast straight down, and you check the distance, and you check all this fun stuff, and you check if you're actually grounded or not. If you're not, you slide down, and it's really cool. It's amazing. You like jump against it, and you slide down. It's amazing. Alright. I'm getting excited over a character control. This is how sad my life is. Alright, box position equals new vector 3. Transform.position.x, transform.position.y, minus transform.local. Like usual, I will explain everything in detail as soon as I finish it. I'm not the greatest at explaining and doing it. So transform.local scale.y divided by 2 minus vector 3.1 divided by 2.y. Okay, you wouldn't have got any of that, and I am not surprised. Okay, what am I doing? See, even I don't get what I do sometimes. Alright, let me explain this to you. Alright, so our box position is where our physics box collider is going to be. Alright, so where we want it to be is we want it to start at the transform position.y. Let me like... yeah, okay. We're going to try to start it here, and we're going to go down, so we're going to divide the whole scale by 1. Do you see this? It's 1. Scale of y is 1. We're going to divide that, and we're going to minus it by the transform position. So, in theory, that should give us this bottom point right here. But we can't take the bottom point. Bottom points are not good. So, we're going to add that to a vector 3.1 divided by 2. So, that should give us somewhere right about here. Okay? So, our box will start here. So that's just a little experimenting that I've done in order to get that, and it works, so I'm not complaining, like usual. Alright, vector 3, so it's just checking over and over, like hundreds of times to see if something works. The vector, the size of our box is just going to be vector 3.1, so it's just going to be of size 1. Alright, before we continue this, I'm just gonna copy this and take it over to our beautiful on-draw gizmos. Gizmo? God, I don't really know how to say it. It's so good. Alright, let's go right here and... Okay, so if we're not grounded, we're gonna go... Your color... I'm not gonna say it anymore, is red. So your color is red. If you're not grounded, if you are grounded, we're gonna go, your color is green. So we have some visual feedback saying, oh, look, your system actually works for once. Alright, and we're gonna draw a quick wire cube. So draw wire cube, box pause and box size. This gizmo is actually the most helpful thing. I would not be able to guess and check all of this. So let's quickly play this. Once, yep, not play it. See, we have this. This is our ground checking. The reason it's so below the player is because if you have a high gravity for some reason and you're falling at super high rate, you have a little bit of leeway to check if you're actually grounded or not. And then our other system that clips you to the ground will manage actually getting you to the ground if you stop early, which you probably will with a decent amount of gravity. Okay, hopefully that made sense too. Alright, I don't know if I'm making sense, but this is gonna work. So you guys can thank me later. Okay, our grounded boolean is equal to physics.checkbox box pos box size divided by 2 because it clearly says half extents. Do not put in box pos like as itself or it will give a really big vector and that's just ugly and you don't want to do that. Okay, so basically it checks the box around this it checks this box, and if there's anything there it returns true. If there's nothing there it returns false. Pretty straightforward. Alright, if you are grounded, okay, so we're telling the system if you are grounded, your current gravity is equal to 0. You don't need gravity if you're grounded, guys. If you're grounded and you have gravity, you're gonna go through the ground, okay? That's how it works. We're not living in the real world here, alright? So current gravity is equal to negative gravity. Alright, so negative gravity is the value that we set on our player before. So negative 0.56. That is perfect amount of gravity. Trust me, you don't want to go like -2. You're gonna die, okay? Don't do that. Alright, so if you're grounded, we're gonna do a bunch of ray checks. You'll be like, why don't you ray check when you're not grounded? Well, that's why we have the box. So the reason we're ray checking now is to check if we are too high above the ground, too far below the ground, if we're stuck to a wall. It's got hundreds of purposes, and trust me, it's one of the most useful features of the whole thing. So we're gonna create one of our most famous rays, and we're gonna go transform the position vector 3 down times 2. I don't know why I'm timesing by 2, but it looks cool, so I'm timesing it by 2. If physics.raycast ray out hit mathf.infinity. Yeah, it's mathf.infinity. Alright, deal with it. Exclude player. Right? The reason I'm excluding player is because I'm raycasting from the middle of the player, so I mean it's obviously gonna hit the player. But I'm pretty sure Unity has some system, but I don't trust Unity. Sorry, Unity. Alright, so if hit.distance is lower than or equal to 2, alright, if it's lower than or equal to 2, we're going to quickly draw a ray from your ray.origin, to your ray.direction, right? And we're going to times this by 20 because it looks cool anyway. We're going to give it a color of green, and we're going to give it a 0.2 f lifetime span thing. Okay, so we're going to create a new vector 3 called needed, and we're going to create a new vector 3. Okay, let's go transform the position.x, right, and hit the point.y plus transform.localScale.y transform.position.z. Alright, let me quickly explain this code. Alright, let's go isometric. Whoa, no, we're still not isometric. That's fine. Oh my god. Okay, this is cool. Alright, so basically what we're doing is, for example, I'm here. Okay, I'm here. What we do is we raycast down. Okay, we get this point on the ground. What we do is we set the position to the point that we hit the ground on. Right? So for a split second, we'll be like this, and then we'll add half of the controller's height to get straight back up and go right on top here. Alright, so you might be thinking, okay, what if my scale is different to my mesh or whatever? So this is where you get a bit creative and don't copy all my code, and you add an extra public variable called height, where in like the Unity controller, that's what they do. They have a height variable that you can modify yourself. You would add that here, and instead of doing minus local scale divided by 2 and all that, you'll be doing minus height divided by 2. Height being the variable that you give us public here. But I don't need that right now because mine's just a capsule, right? I don't need that, but I will soon when I start adding awesome meshes in mine. But I haven't yet, so it doesn't really matter right now for me. Alright, so I explained that logic quite well, I think. And easiest thing in the game, which is in the whole code, we're just gonna transform position is equal to needed. So we're just gonna snap it straight to needed. Yeah. You might be thinking, well, won't that override other movement and all of that? Why do you think gravity is at the top of the code? I planned this all out, okay? Trust me, I know what I'm doing. Alright, okay, alright. And we're gonna go else if, alright, hit distance is greater than 2. Okay, so this is in the case that we're right next to the ground. If you're not next to the ground, okay, this is the scenario that I was talking about before. You jump and you're stuck in this wall. Right? This is a normal thing that happens even in the character controller. You're stuck in this wall. What do? Normally people will be like, oh, attach a physic material which is slippery. No, that's a hacky way to do it. That's terrible. Don't do that. Be smart. Alright, so all you're gonna do is if the hit dot distance is greater than 2, right, you're up here, yet you're still getting hit down here, and your distance is greater than 2, that means there's a ground greater than, like, you're not grounded. So all you just gotta do is grounded is equal true. You're still grounded, mate. No. But I know you set it up here, but you're just overriding it. You're not grounded. Trust me, you're not. That's all you're saying. Time gravity is equal to negative gravity times 0.5f. You might say, why is it times 0.5f? It's not perfect yet, so it needs that. I have no explanation for that. I think it just needs this. I don't know. You know what? I didn't even think we need that actually. Yeah, we don't. Can we just test this? I'm not 100% if this would be working at this point right now. And of course it does. Whoa, you see? It works. And every single time you will be perfectly aligned with the ground. Exactly aligned with the ground. No matter how high I put it, right? It will fall and it will align with the ground, right? The split say, look, I am actually clicking and dragging this down. It won't work unless it clips all the way through. Please tell me it's not clipping all the way through for you. If it's not, if it is, your gravity is just too high. Okay, you're too high. Alright. Capsule. Alright. If you want to increase your gravity, just go 6. Alright. Oh no, what am I doing? That's my sensor local. No. My gravity is here. I'm so dumb. Sorry. It works with anything. It's quite fast gravity. It still works. Alright. I throw you. Okay. Alright. Yeah. Okay. That was forced. The reason it didn't work. Okay. So, imagine you jump, okay, and you're stuck here. What happens? You fall. You fall. But look, the box is colliding, yet you still fall. Why do you fall? There's a ray. You see this ray? There. What if I'm... Oh, go away. Let me demonstrate. Oh my god. What if I'm stuck here? You still fall. Is it smooth? Yes, it's smooth. Of course it's smooth. I made it. Alright. I am really exhausted. This has been going for a while now. The final best part of this... Oh yeah, by the way, slope detection will work right now. I think, according... It should. Trust me, it should. Alright, I just put you over here. And using my amazing tricks, I'm just gonna... okay. I'm just gonna get my main camera and snap it to this angle. Of course I am. Alright, let's just watch as this beautiful controller... Okay, you know, this move speed is actually really annoying me. Hold on. Move axis speed. Let's just bump this up to 0.08. A solid 0.08. My oldest scene needed quite slow. Alright, before I show you how amazing this controller is at climbing slopes, right here. Look at this. Okay. Alright. I'll explain exactly why that was in a second. Alright, that was by no means a problem with the controller, okay? Just trust me on that one. Let me, Command F here. Oh. Trust me, no problem with the controller. It's my little orthographic view. Alright, so the problem here is that my mouse controller script isn't actually perfect. So if I leave my mouse at a position, the player comes there and he doesn't actually know which way to go. This is not a problem with the controller. This will work perfectly for you guys. I just need to optimize my mouse controller script a bit. But if I go over here, oh, okay, my direction needs work. But look at this. Look at this. It's beautiful, right? It works perfectly. Look at this. Look at this. And it falls off the slope. Alright. Watch this, watch this, watch this. Right, ready, ready? And it descends the slope perfectly. See, it's for like camera placement right now. I wish I could have proper camera placement. So I could demonstrate this working quite properly. I hope you see that this is working. This is actually really cool because most traditional ways of actually doing this don't include this. So as you can see, it is finding a cross product, and I'll explain to you. This is actually our little code here. So this does most of the work, but as you can see, half of the time, those rays don't show up. Rays don't show up. They only show up some of the time. So you'd be asking yourself, how does the slope detection and climbing actually work? It works through our gravity system. So our gravity system just helps that. And the other way is just our ray. So we should have a... No, that's fine. And everything is actually working really well. It's amazing. So this system, of course, can be used in FPS situations. And let's get into the last part of the video. And I'm really excited. And this took a while without physics because I'm a physics guy. I like the Unity's physics system. But when I tried to make a controller with it, no, it just did not work for me, and I just wanted everything to be my own. I'm just one of those guys who just don't like using things that come with the engine. You know, the point of an engine, but like, I don't like that. I'm sure heaps of other people could relate. Alright, so, we can only jump if we're grounded, guys. It's just common knowledge. But if your game has double jump or something that's easily implemented, you can do that. I can't go through every character control system ever, but I'm going to give you the basics. If your jump height... Okay, so this you might not understand. Let me explain to you quickly what this is. Alright, so if you're grounded and you're still jumping for some reason, okay, so your jump height controls how high you are in the air. If you are grounded and your jump height is still greater than 0, you've got a problem. So you need to reset that to 0 as soon as you can. Alright? So basically, it prevents you from, like, there's normally this little jittering that happens because you're not setting to 0, and a couple of problems. Just trust me on this, being tested by a million times by me. Okay, so if I get a key down, keycode space, alright? Jump height plus equals jump force. Alright, okay, easy. Let's explain this. If I get the key down and the key is space, we all know this, inputs, easy stuff. You're going to increase the jump height by the amount of jump force that you give, which is a public variable at the top. So if we increase this, what happens in our final movement, little final movement here, all it's going to do, it's going to increase the y by that incrementally. So it's not going to instantly go up and instantly come down. No, I want smooth, linear. No, I don't even know. I'm not smart. Okay, I just want smooth jumping. Okay, I just know it looks right. Okay, I just want that. Alright, it's smooth. Trust me, it's really smooth and it's really cool. No physics involved. or your own gravity system. And I think this is like one of the few YouTube videos online that actually cover custom controllers that actually implement everything like from scratch without using the stupid Unity character controller, which is absolute trash. Okay, never use it. If you're making a professional standard game or even an indie game, okay, do not use the character controller. Even games like Unturned, do not use the character controller. Okay, it is not good, not good at all. All right, so if we are not grounded, guys, we need to decrease. Okay. I need to take this step by step. If we're not grounded, all right, this is if we're not grounded, and our jump height is greater than 0, we need to start gradually bringing it down. We can't just say if we're not grounded and we're in the air, set the jump height to 0. No, you're just gonna go up and down really quickly. We don't want that. We want it smooth. So we're gonna minus it by a jump height times the delta time. This smoothly brings it down. Trust me, I've tried it. It works. Okay. And if the jump height is not greater than 0, and it's like, for example, lower than 0 or equal to 0, just set it to 0, okay? This is a perfect jump system. It works. That's it. What is this? 1, 2, 3, 4, 5, 6, 7, 8, around 10 or so lines, and we've got a jump system working. That normally doesn't happen. You gotta use dirty physics and velocity calculations and add force and all that, and then it screws up other calculations, and it's just not cool, alright? So what we're going to do, we've got to jump. Alright, let's quickly test this. We're on the ground. Okay, this is a really short jump. You really want to see how cool and smooth this is? Let's set it to 0.5. I'm gonna stay back here. And whoa! Yeah, it's smooth. It's smooth. And, okay, you know what? I'm going to make this interesting for you guys. I want to add a quick variable. And we're going to call this, actually, it's gonna be here. Public float jump decrease. And we're gonna go right here and we can be like times jump decrease times delta time. Alright, so we can modify how quickly we fall after we jump. So let's quickly test this. We wanna quickly descend. So I'll set this to 1.7. Less than 1 would be less than the average. Okay, let's increase this. Yeah. Okay. If I increase this, you see, it brings it down really quickly. We don't want that. That's a bit too much. But you see, there's actually I like that. I like that. I like that a lot. 4.3, and we got a little realistic jump, and it even takes. Oh my god. Okay, I'm so sorry about this. I keep forgetting to set this to 0.5. Okay, ready? You got a little jump, and the best part, it takes into account direction, so it follows the direction. And you might be thinking, oh, this is a bit not smooth right now. It is really smooth. It's just my system lagging a bit right now. You can jump down smooth slopes. It's beautiful, right? It's amazing character controller, and we didn't use a single physics system. And I don't know how long this tutorial took, but in a relatively short time, we've got collision detection with proper account for all walls, right? We've got slope control. We've got descending slopes. We've got coming up slopes. We've got jumping. We've got gravity. We've got... This is amazing. This is like everything in one tutorial. Normally, this would spread across 5 tutorials for a normal guy to teach this. And I'm actually really happy I got this out there because I've been searching for this for an extremely long time. And like a proper way to do this, I'm like, no. You know what? I'm going to do this myself. I'm so glad I did because I can share this with all of you. And yeah, I'm really happy, and this is going to help me in my game. And if this helped you, and if you even mildly enjoyed this content or learned anything at all, I want you to leave a like. a comment on what I can improve and what I should do for my next episode. And just please subscribe to see more awesome content like this. Thank you for watching, and until next time.